Next mechanism is oxidation of 2-degree alcohol by k2cr2o7 in dilute sulfuric acid. In previous video, we have covered 1-degree alcohol oxidation by k2cr2o7 and its mechanism. Now here we have 2-degree alcohol. Topic is not included in the syllabus of 12th class. It is for JEE Advanced and B.Sc. 2-degree alcohol on reacting with k2cr2 and dilute sulfuric acid firstly will create ketone, which will further oxidize to carboxylic acid plus alcohol, which will further oxidize directly to aldehyde and carboxylic acid. Means final compounds will be carboxylic acids. Now let's check what is the mechanism behind it. How k2cr2o7 is converting into chromic acid, that already we have discussed in previous video. So we will not repeat it again. So directly I am going to use them. This is the general formula of 2-degree alcohol. OH connected with carbon, which is directly connected with 2 carbons. And k2cr2o7 will react with sulfuric acid and water to produce chromic acid. That will be your main oxidizing agent here. Chromic acid is bringing whole reaction. Chromic acid, this is chromic acid, which was generated from k2cr2o7. Chromic acid is more strong acid as compared to alcohol. So what it will release? H positive. Due to which these electrons will shift toward oxygen, due to which this particle will become anion. This oxygen will get extra electron of hydrogen, so negative charge, and already it have 2 pairs on it, so total 3 pairs will be there. This is H positive vacant orbital. What it wants? Electron, because it's a electrophile. Where we have electrons? This oxygen have electron, lone pair. So let's attack on it. Due to which this oxygen will become unstable, because third bond it is making with hydrogen, and that bond is dative bond. Out of 2 electrons, 1 electron it is completely transferring to our hydrogen. That's why it is getting +1 charge. In this condition, oxygen is unstable, will start breaking bond from carbon, and obviously electrons will shift completely toward oxygen, due to which there is a release of H2O. And what about this carbon? Because it has lost its electron, so vacant orbital with a positive charge will generate. Let's draw this vacant orbital and positive charge, which will be satisfied by this oxygen, because this oxygen is carrying extra lone pairs. That's why it is also unstable. This is unstable, this is unstable, both can satisfy each other, so that's why they are going to make bond with each other. Now between carbon and oxygen, dative bond will be there. So out of these 2 electrons, 1 electron is completely transferred toward carbon. That's why its +1 charge is finished. And because it has shifted 1 electron toward carbon, so its negative charge is finishing. In this fashion, they are stabilizing each other. What is generated? Chromate ester. In previous video, I also told you this is a main intermediate, chromate ester. In chromate ester, this part, strong electron attracting group, strong electron attracting group. Why it is strong electron attracting group? Because a lot of oxygens are available, and we know oxygens are highly electronegative atoms. So what is happening? These electrons are strongly shifted toward this side. That's why this carbon will start attracting electrons strongly from its hydrogen, due to which this hydrogen will become highly positive, means acidic. This is acidic hydrogen now. This is the role of chromate ester over here. In previous video also we have understood it. Now let's check what will happen next. This hydrogen is highly positive, means acidic, so it will be attacked by base. Who will provide a base here? H2O. Water molecules are available. Dilute conditions we have, and already in first step extra water molecules were released out. Now H2O we know can break in two part, H positive, OH negative. So this is the negative particle, this is a base, this is a H positive particle, it will attack on it, due to which bond will break between carbon and hydrogen, and obviously electrons will shift toward carbon side because carbon is more electronegative than hydrogen. H positive, OH negative, they will satisfy each other with the release of H2O. Now this carbon will shift these electrons, this pair of electron, toward oxygen side because this part is attracting electrons. Due to which this oxygen, as we know, oxygen is stable with two bonds. So if this bond will generate here, this bond will break, and obviously electrons will shift toward chromium because these electrons are coming here. So due to repulsion, electrons will get shifted toward chromium side. And please check what is generated here. This bond is already broken. Carbon has made with oxygen. This one. What is this? This is ketone. And here we have a release of this particle in which chromium is showing +5 charge. Here it was partially +6. Reduction is happened there. Its oxidation is happened, its reduction is happened. So ketone will generate if you will oxidize 2-degree alcohol by k2cr2o7. This is the first step. Can ketone oxidized further? Yes. How? Suppose one ketone I am using, proper ketone I am using. To understand the concept better, this ketone, suppose this was generated, how its further oxidation will happen? Number one, it will not get oxidation in this form. Aldehydes were there, they were creating hydrates. Ketones will create enols. In previous videos, when we were dealing with the mechanism of KMNO4 and in the oxidation of ketone, I have already told to you, ketones first convert themselves to enols in strong acidic conditions. How they will convert themselves to enols? We know sulfuric acid is available and you need to heat it. In hot conditions this will happen. Sulfuric acid will provide H positive particle which will start attacking on oxygen because oxygen is negative here, due to which pi electrons will shift. Carbocation will generate. Now this carbocation, this carbon with a vacant orbital can be satisfied by two sides. Either from right hand side like this carbon will shift its electron toward this carbon, vacant orbital, two electrons will make bond and hydrogen will release out as H positive, and that H positive will bring this reaction again with another molecule of ketone. So there is a first possibility. This enol can be generated. En means double bond, ol for OH, enol. Yesterday also we have discussed same mechanism it was. Second option, from this carbon, this is alpha carbon, this is also alpha carbon. If I am using this alpha hydrogen, this alpha carbon, so enol generated will be this one. This is another enol. This enol will be in major amount, this enol will be in minor amount. Reason yesterday I also told you that hyperconjugation. If you are making enol from smaller alkyl group, less hyperconjugation will be there, less stability. And if you are making from bigger side, more hyperconjugation will be there, more stability. So for further oxidation product, I am going to use major number of particles. This enol I will use. How this enol will be further oxidized? Let's check. So once check this, ketone will directly not oxidize itself. First, in acidic conditions, it will create their enols. These enols will further oxidized. No problem, you can make products from this enol also, but though that product will be in minor amount. So I am not drawing them. I am using major enol. What is our major enol? This is our major enol. This one. Now how it is going to be oxidized by chromic acid, please check. As we know, this is the condition of chromic acid, in which chromium have strong +6 charge due to sharing of 6 electrons with these strong electron attracting atoms, oxygen. 6 electron it is transferring toward oxygen, that's why it is carrying +6 charge. Means it have a tendency to attract electrons, means chromium is working as an electrophile. Who can provide electrons to it? Here we have electrons. Two options we have. Oxygen lone pair? No, because oxygen is highly electronegative. Second option is available. Pi electrons. Pi electrons are always soft target for electrophiles because they are perpendicular to the molecule and they can be easily attacked by the nucleoelectrophiles because they are weakly holded by the atoms. But can directly it gain this pi electron? No. Same like KMnO4 case. First, this oxygen is coming near to this carbon, so these pi electrons will shift toward oxygen side, due to which these pi electrons will be further pushed toward chromium side. Indirectly, it is getting electron. Check. This oxygen is coming near to this carbon, so it will attract electrons. Which electrons? Pi electron. These pi electrons will come toward oxygen, and obviously oxygen is stable in making two bonds. So this bond will break and these electrons due to repulsion will be further pushed toward chromium. Now what will be the next condition? Because this carbon is losing its electron, so it will become strongly positive, means a carbocation, and between these two carbons double bond will break, only single bond will left, OH as it is, CH3 as it is, and this bond, this carbon will use to make with oxygen because it will transfer these electrons for bonding with oxygen like this. These pi electrons will be further shifted toward chromium, means here single bond will left that I am drawing, and two electrons will be there on chromium, OH as it is, OH as it is, and here we have double bonded oxygen. Now due to this vacant orbital and a positive charge, pi electrons of oxygen and chromium will get shifted toward this bond, this vacant orbital, and bond formation will happen because oxygen is negative, as you know, partially negative due to higher electronegativity, so it have a tendency to shift these pi electrons for the vacant orbital. So between this oxygen and this carbon, bond will break, bond will generate, that I am writing here directly. Let's draw it. This one. So the positive charge of carbon will finish because one electron is completely transferred toward carbon, one it is keeping with itself. This will be the condition. Now this is what yesterday we have also discussed it when I was doing the mechanism of KMnO4. It is cyclic chromate diester. Due to this cyclic structure, crowding is there, that's why this bond will become weak, due to which it will start to break. How it will break? Let's break it. Suppose we are breaking it like this. Both electrons are shifted toward oxygen, because oxygen is more electronegative as compared to carbon. So when bond will break, both electrons will completely shift toward oxygen like this. Oxygen is stable by making two bonds. So this bond it will break and these electrons will go toward chromium. Because this electron is going toward oxygen, so this carbon will become positively charged, vacant orbital will generate, which will be satisfied by the neighbor oxygen by breaking bond from chromium and shifting these electrons here. So this will be the movement of electrons, due to which we will have double bond here between oxygen. This bond will break. So now chromium will have two already electrons. Keep in your mind, out of these two electrons, one electron was of oxygen and one electron was of its own. Same here. In these two electrons, one electron is its own and one electron is of oxygen. OH, OH, this will left. And these electrons, as we are shifting toward this carbon and bond between carbons has been broken, now this will generate. Which particles we got? This is aldehyde and this is carboxylic acid. Now we know because carboxylic acid contains two carbons, so its further oxidation is not possible. Yes, aldehyde can be further oxidized. Already we have done mechanism. First it will make its hydrates and those hydrates will react with chromic acid. Mechanism we have already discussed. You can check it. Now students are sometimes confused that is it necessary to shift these electrons that side? No, it is not necessary. You can shift it to that side also. Same products will generate. Check. If I am shifting these electrons here, oxygen this side also, because oxygen is highly electronegative, so it can attract electrons. So both electrons are going to that side. Now because this carbon is losing its hold on electrons, so here we will have a positive charge, which will be balanced by this oxygen like this. Now because here electrons are coming, so these electrons will feel repulsion and will shift to chromium. So in this fashion you can also break a bond. Same product will generate. From here bond will break. Between this carbon and this oxygen you can check double bond will generate. CH3, COH. Between this carbon and this oxygen double bond will generate. So and you can check two pairs will come on chromium with a OH. Same it is like previous. That's it. This is the end of the video. 2-degree alcohol oxidation by k2cr2o7. First it will create ketone and ketones will further oxidized through enol generation. And enols will get further oxidized by the generation of cyclic chromate diester, which is crowded, which is unstable, due to which carbon-carbon bond will become weak and they will start to break. In this fashion they will break and these compounds will be generated. If carboxylic acid is there with two carbons or more than two carbons, we cannot further oxidize it. If one carbon is there, you will oxidize it. Aldehyde will further oxidize. First we need to convert them into their hydrates and those hydrates will further react. Next video we will check 3-degree alcohol mechanism, its oxidation with the help of k2cr2o7. Thank you very much for watching the video.